Good day, viewers. My name is Sheripo Shuareko. Welcome to our program 2 of our computer series for the grade 10 and 11. Our lesson today is on logic circuit. Now, by the end of this lesson, you should be able to produce truth table for given logic circuits, maximum of 2 inputs and 4 gates. Right, viewers, we are going to look at how to produce a truth table now for the following logic circuits. Right, as you can see, there are 3 inputs for the logic circuits. Therefore, there will be 8 possible binary values which can be input. To show stepwise how the truth table is produced, the logic circuit has been split up into 3 parts, and intermediate values are shown as P, Q, and R. Right, viewers, the first part of the logic circuit is the first task is to identify the gate. In this case, we have the AND gate and the NOR gate. And the second task is to find the intermediate values of P and Q. Right, now the value of P is found from the AND gate where the inputs are A and B. The value of Q is found from the NOR gate where the inputs are B and C. Viewers, we are going to produce intermediate truth table using the logic function. To find the value of P, remember the rules for AND gate. The output P is 1 if both inputs A and B are 1. Now let me run through. 0 and 0 equals 0. 0 and 0 equals 0. 0 and 1 equals 0. 0 and 1 equals 0. 1 and 0 equals 0. 1 and 0 equals 0. And 1 and 1 equals 1. 1 and 1 equals 1. Whilst to find the value of Q, remember the rules for NOR gate. The output Q is 1 if neither input B nor input C is 1. Alright, let's go through the list. 0 or 0 equals not. 0 is 1. 0 or 1 equal not. 1 is 0. 1 or 0 equals not. 1 is 0. 1 or 1 equals not. 1 is 0. 0 or 0 equals not. 0 is 1. 0 or 1 equals not. 1 is 0. 1 or 0 equals not. 1 is 0. 1 or 1 equals not. 1 is 0. Now, viewers, the second part of the logic circuit has P and Q as inputs and the intermediate output R. Let's continue to the second part of our circuit to create a truth table for the second part of logic circuit P and Q. Viewers, before we continue with the second part of the truth table, note that even though there are only 2 inputs to the logic gate, we have generated 8 binary values in the first part, and these must all be used in the second truth table too. Now, we are going to produce intermediate truth table using the logic function of OR gate. R is positive, which is 1, if the input of P and Q are either positive which is 1. R is negative, which is 0, if P and Q are both negative, which is 0. Note if P and Q is positive, which is 1, the output will be positive, which is 1, meaning at least one input has to be positive, which is 1, to give a positive output. Right. Now viewers, let's look at the final part of the logic circuit, which is R and C as inputs and the final output X. This gives the third intermediate truth table as it is shown here. Now put in mind the XOR gates rules. The output X is 1 if input R is 1 and input C is 0, or input R is 0 and input C is 1. So to find the value of X, 1 and 0 equals 1, 0 and 1 equals 1, 0 and 0 equals 0, 0 and 1 equals 1, 1 and 0 equals 1, 0 and 1 equals 1, 1 and 0 equals 1, and finally 1 and 1 equals 0. Viewers, we are done with our 3 parts of our truth table. However, we still need to put all 3 intermediate truth tables together to produce the final truth table, which represent the original logic circuit. The intermediate values can be left out of the final truth table, but it is good practice to leave them in until you become confident about producing the truth table. The final truth table would look like this, as you can see here. Well, viewers, we have come to the end of our lesson for program 2. We have looked at how to produce a truth table for the given circuit with the maximum of 2 inputs and 4 gates. Alright viewers, before we conclude our lesson for today, I would like you to produce truth tables of the following logic circuits. You are advised to split them up into intermediate parts to help eliminate errors. Alright viewers, we have officially come to the end of our lesson for today. I hope this lesson was informative. Until next time, bye-bye.